Student, we will discuss about the basic concepts in object-oriented programming. Firstly, we discuss about objects. In previous class, we discussed about objects. Objects are basic runtime entity, and storage is allocated to objects. So, objects can have state and behaviors. We discussed in detail in previous class. So I will not discuss in detail. Then we discuss about some examples of objects with their state and behavior. So today our topic is classes. A class defines the type of an object. A class is prototype, template, or a blueprint of an object. Basically, class is a structure and the object use these classes. A class is a specification common to all objects of a particular type. This specification contains the detail of data and function that act upon the data. Objects of a class are called individual instance of that class. Any number of objects can be created based on the class. So student, class is just a structure and object use that class. When we create a class, storage is not allocated. Storage is allocated at the time of object. So there can be number of objects of an class. Basically, class contain our variable that is detail of data and functions. In class, we define our variables, that is data members and member functions, and objects use that data member and member functions. Let us discuss about it with our daily life example. We design a house on a paper, that is class, and architects design a house. Architecture on paper is a class, and when we build a house in real world, that is object. So we can build number of houses from one designer. So a class can have number of objects. So when we create objects of class, the syntax is class name, then object name. If our class name is shape, then we will write shape, and we want to design a object S1, then we write it shape S1. There is also mention an example student Shahid and Kerman. If we want to create two object Shahid and Kerman, then we write class name, then object name separated by comma. If we want to define only one object, then we write student Shahid and semicolon. We will discuss about in detail when we study our topic classes and objects. So in object-oriented programming concept, you just know about what is object, what is class, and what is the difference between object and class. As we study that class is just a blueprint. So here tree class, and there is number of objects of a class. There in diagram there is 4 objects of class. So from class we can create number of objects. So now what is the difference between class and object? Class is collection of objects with the same attribute and common behavior. Basically in class we define data members and member functions, and object operate on that. So Data and function that operate on data are bind together to form an object. Class is just a specification or logical entity to create objects, and objects are real world entity. As we discussed about one example, class is just a structure, just a design of our house, and object used as design in real world. Classes does not consume space in memory. So storage is not allocated to classes but allocated to objects. So objects occupy some space in memory. A class can have many objects. Object is a instance of a class. When we define a class, we can create number of objects of that class, but object is instance of a class. Object will be referred to one class. Means if we create a object of shape class, then s1, then s will be referred to class shape. Class is a static entity. Means when we create a class, it is static. Means function we can modify it, but is a static in nature. If we run or implement one time, two time, three time, it will be same, it will be static. But object is dynamic entity and has limited time span. So object can be dynamic. When we create a object s1 and s2, so s1 will have limited lifespan. So there can be different forms of different objects. If object one, for example, contain roll number one name Ram, and roll number two contain name Rajesh, so object is dynamic because object hold different data at runtime, depend upon user requirement and user input. So class is static, it never changed if we run it a multiple time. So at last there is example of class and object. For example, furniture is a class, and objects can be table, chair, sofa, etc. Our next concept is message passing. Objects can communicate with each other by passing message, same as people pass messages to each other. We communicate with each other through messages. Similarly, objects can communicate with other object or classes with help of message passing. Objects can send or receive message or information. A message to an object is treated as a request for execution of its function. When object send a message, it is treated as a request to execute a function. The object that receive a message implement that request, means execute that function and return the output of that function to object. So message passing involves sending a message from one object to another object in a system. On receiving the message, the suitable function the object is invoked and desired result are generated. When a object A1 send a message to object B, so when object B receive a message, receive a request from object A, it implement that function and return the output result to object A. A message comprises of name of object, name of function, and any information to be sent to the object. Now, how message passing is worked? How an object pass a message to another. There should be name of object, name of function, and any information to be sent to the object. Let us discuss it with the example. For example, in banking system, Customer often need to check their balance. So customer object simply send the message get balance to the object account by passing information account number as shown. If a customer in a bank want to check their balance, so there is requirement of account number. With the help of account number we can get our balance. So the sentence for this is account dot get balance account number. Account is a name of object. Get balance, the function we want to implement message get balance that will return the balance to the customer. And account number is required to check the specific customer account detail balance about balance. So here object dot function name, we discuss about it in last slide. Firstly object name, that is our account, and secondly name of function, that is get balance, and information here required is account number, so we pass account number as a parameter. That's all about message passing. So our next topic is abstraction. Abstraction refers to representation of necessary features without including internal details or explanations. Abstractions basically hiding the internal complex detail from the user. So for this, in OOPS, we use class because class encapsulate the relevant data and function that operate on data by hiding the complex implementation detail from the user. Basically, class is a class contain data and function, and there is access specifiers that restrict the access to that class. So class encapsulate relevant data and function that operate on data by hiding the complex implementations from the user. So data abstraction is programming technique that rely on the separation of interface and implementation. So abstraction helps to separate the interface and implementation. Interface is viewed by the user and implementation is execution of our code. Implementation denotes how variable are declared, how functions are coded, means implementation contain our coding part. It through interface our communication is sent to object as a message. So due to abstraction, implementation is viewed by the programmer and interface is viewed by the user. Let us discuss about abstraction with the help of an example. So when you press a key on your keyboard, the character appears on the screen. You need to know only this, but how exactly it works electrically is not needed. So when we press a key from our keyboard, we just system just display our character on the screen. It does not display us how this key is converted into electronically. Another example is when we use the remote control our TV. You don't bother about how pressing a key in remote changes the channel on the TV. You just know that pressing plus volume button will increase the volume. We doesn't know about the internal implementation of data operations. Let us discuss about it with another example. We use net banking when we log in with our ID and password. If it is correct, then we will log in, otherwise it will display us an message. So we doesn't know about how our username and password is matched at the backend. So we just deal with our interface, we doesn't know about the internal details. So abstraction provide us that feature. So what is the advantage of abstractions? User gets benefit. Firstly, the user that use that software application gets benefit from this because they do not worry about the complex implementation detail of a function. As we discussed in net banking, we does not worry about the complex implementation at the back end, that how they check our balance, how they um, match our login details. So user doesn't bother about that. So what is the benefit for a programmer? Programmer takes the advantage of abstraction by modifying the internal logic of the function without changing the interface. If a programmer want to change or modify an internal logic and want to add a new function, then it can be changed without changing the interface. We use multiple applications and we update our application. There will be some new features. So programmer doesn't uh, think about the interface, means he or she can be change the internal logic, add some new features without disturbing the user. If we are using our old version, then we deal with the old functions, and when we update it, then modified or new functions will be added. Our next concept is encapsulation. In simple words, encapsulation is a process of binding data members and member function into a single unit. Capsulation. From capsulation, we can discuss about this topic with the example medical capsule. In capsule, medicines are wrapped in a body. So similarly, in object oriented programming, our data and function is binded into a single unit. Object is like a capsule, and data and logic is a medicine stored in that capsule. So encapsulation is a process to binding data members and member function into a single unit. So data is not accessed to the outside world, and only those functions which are wrapped in class can access it. These functions provide the interface between objects in objects data and program. This insulation of the data from direct access by program is called data hiding or information hiding. Class is best example of encapsulation. So class is an example of encapsulation because we write our data member and member function in a class. If we define a class as private, then it cannot be accessed outside. Only the function of that class can be accessed it. So it also provide data hiding because nobody can access it without permission. If class is private, then it cannot be accessed outside the class. So data is not accessed to the outside world. For example, medical store. Let's see, you have to buy some medicine. You go to the medical store and ask the chemist for the medicines. So only chemist has access to the medicine in the store based on your prescription. The chemist know what medicines to give to you. This reduce the risk of you taking any medicine that is not intended for you. So here medicines are encapsulated in our class, for example, and chemist is the outside layer that restrict the access. So if we want to buy a medicine, then chemist will give us as our prescription. We can't take at our own choice. So similarly, in object-oriented programming, if we want to access the data of any class, then a data member will access it, not other member of other class can access it directly. So in this example, medicine, our member variable, giving medicine by chemist, our method means our function, and you are external application or piece of code. You are external assessor. So an external entity cannot assess the encapsulate data. So basically encapsulation is a process of binding data members and member function together. If we want to use that member function, then we can access through member function of that class. We cannot access it direct. So our next topic is inheritance. Inheritance is process by which object of one class acquire the properties of object of another class. Means if a object inheritance means if we have a class A, it has some features, and we have a class B. So if we inherit class A in class B, then class B will contain all feature of class A, all public function of class A plus some additional functions. No, Sonu Kumar. All students are unmuted. Object-oriented programming, the concept of inheritance provide the idea of reusability. What is the benefit of inheritance is reusability, because if class B have some features of class A, then we have not to write it again, and we can use it with the help of inheritance. This means that we can add additional features to the existing class without modifying it. This is possible by deriving a new class from existing one. The new class will have combined feature of both classes. As I discussed about it, we can combine features of both class without writing it again, because class B contain some function of class A by inheritance plus some additional feature of class B. Let us discuss about it with the help of an example. Consider an example of family of three members: mother, father, and son. For example, son name is Jack. Jack father is tall and dark. His mother his mother is short and fair. So Jack can be tall and fair. Plus, there can be some additional features. He is said to have inherit feature from his mother and father respectively. So tall is feature of Jack father and fair is feature of his mother. So tall and feature are inherit from their father and mother, and there can be some additional features. So it is about inheritance. Through effective use of inheritance, what is advantage of inheritance? You can save a lot of time in programming and also reduce error, because we write these functions once and can be inherited and in another class without writing it again. So if there is any error, so we have to correct it in base class. So inheritance also increase the quality of work and productivity, because if we want to change some function, then we have to need to change it only once. So we can use it a number of times without writing again and again. So we will explain about inheritance in our topic, in our chapter inheritance, in detail about the types of inheritance, how we use it. So we will discuss about it in our chapter inheritance. So our next topic is polymorphism. Polymorphism is important object oriented concept. Polymorphism is a Greek term. So word polymorphism coming from the Greek, which means ability to take more than one form. Polymorphism and operation may show different behavior in different instance. So if we have a class and there is number of objects of that class, and then there can be more forms of that. Means for example, we have class shape and object one draw shape of sphere, object two draw calculate area of square, object one calculate the area of square, object two calculate the area of rectangle. So there can be multiple forms. So in polymorphism and operation, that is calculation of area, may show different behavior in different instances. So poly means many and morphism means forms. So polymorphism means many forms. There is another example of polymorphism. For example, we use addition symbol. It used to make sum of two numbers, as well as it is used to combine two strings. So plus symbol is used to sum two numbers, as well as we can combine two strings. In C, we can add only integers and float values with help of plus symbol. But in C++ and Java, we can combine strings with plus symbol because of operator overloading. Because same operator may behave differently on different instances. So here plus symbol can add two integers as well as two different strings. So here there is more than one forms of our addition symbol. Similarly, there can be a sum function taking two arguments or three arguments. So basic function, our basic function is sum, and there is the many forms of sum function. Is first one is taking two argument, and second one is taking three arguments. First sum 5 and 7. Here sum is taking two arguments, and sum 4, 6, 8. Here sum is taking three arguments. So our function sum have many forms. So our next example is draw function. As we discussed in previous, here we have a function draw shape. So we can draw circle, draw box, and draw triangle. So there is many forms of our draw function. So our next topic is dynamic binding. Dynamic binding is process of linking of code associated with a procedure call as runtime. Basically, there is a two type of binding: static binding and dynamic binding. So in object oriented programming, we are discuss about dynamic binding. Means at runtime, if we define a function sum and call it somewhere in the code, so that some call will be connected to our some function definition. So when we call, it goes to the definition of some function and implement that code. So that binding can be done at runtime and compile time. So the binding done at runtime is known as dynamic binding. Code associated with the procedure call, linking of code associated with that function call at runtime is known as dynamic binding. Dynamic binding means that the code associated with a given procedure call is not known until the time of call at runtime. So in dynamic binding, we not know about it before running. We know about the binding at runtime. When we call a function, where our control will goes, that will be decided at runtime. So that's about the object oriented concepts. Introduction to Java. Java developed by Sun Microsoft in 1991 by James Gosling and Parth Norton, and later it is adopted or it acquired by Oracle Corporation. And in 1995, it is launched officially for public. Although Java was developed in 1991, but it launched publicly for in 1995. It is a simple programming language. Writing, compiling, debugging a program is easy in Java. It helps to create modular programs and reusable codes, because uh, we can use inheritance in Java. Before start learning Java, let's get familiar with the common Java terms. Firstly, JVM, Java Virtual Machine. I think we discussed about it in our lab lecture. So I repeat it again. Basically, primary function of JVM is execute the bytecode produced by compile. When we write our Java program, firstly we compile it, and Java compiler converts source program into bytecode, and then bytecode is executed by JVM Java interpreter, and JVM provide environment to execute or run bytecode. Each operating system have different JVM. However, the output they produce after execution of bytecode is the same across all the operating system. That's why we call Java as platform independent language. As we write our program on Windows and compile it, then we want to run that bytecode on Linux, then we can execute it with help because of JVM, because JVM for each operating system has different JVM. For Linux there is Linux JVM, for Windows there is Windows JVM. So that's why bytecode can be executed on the other platform, and it makes Java platform independent. So what is bytecode? Java compiler compile the source code into bytecode. Bytecode is also known as intermediate code, because from source code we goes to bytecode, and then from bytecode we goes to machine code. So Java compiler compile the Java source code into bytecode so that it can be executed by JVM. We save our Java program with the .java file. Bytecode is saved as .class file by compiler. For example, our program name is hello. So hello.class will be bytecode of our hello class program. Then there is a JDK, Java Development Kit. As from the name, it's clear that there will be some tools that will be used or helpful in our Java development, Java program development. So Java Development Kit includes JRE, Java Runtime Environment, compilers, and various tools like Java Doc, Java Debugger, etc. In order to create, compile, and run Java program, we would need JDK installed on our computer. If we want to write or create our Java program, compile and run it, then JDK is required, because JDK provide us development in, we can say, development environment, as well as for writing, compiling, and running. In simple words, we can say JDK contain all tools that are required to develop Java applications. Then another term is Java Runtime Environment, also known as JRE. JRE is part of JDK. As we studied in last slide that JDK contains JRE, compiler, and other tools. So JRE is part of JDK, which means JDK include JRE. When we have JRE installed your system, you can run a Java program. However, you would not be able to run it. Basically, JRE helps to run our Java program. JRE include JVM, browser plugins, and applets code. Java runtime environment is required to run Java program. So for running a Java program, we required JVM, because JVM provide running environment for Java bytecode. So JRE means Java runtime environment include JVM, browser plugins, and applet ports. When you only need to run a Java program on your computer, you would only need JRE, because JRE will help to run the program. So for running, we can have only, we required only JRE. For if, but if we want to compile it, then compiler is required. So basically JDK provide us tools for creating, compiling, and running. For compilation, we required Java compiler, and for running, we required Java runtime environment, JVM, browser plugins, and applet port. So for running, it help Java runtime environment will help us, and it include JVM, browser plugins, and applets. That's about the Java and Java terminologies. There can be questions on these terms in interview as well as in exam. Our topic is stages for Java. There can be 5 stages for Java. Firstly, edit, compile, load, verify, and execute. For editing, we use editor. Means when we write our Java program, we use the editor. Then compile. When we compile our top program, then we required Java compiler. Then in load stage or phase, there is a class loader. Then at phase 4 or stage 4, there will be bytecode verifier, and at the last there will be execute. And we, as we know that execution means running will be done at JVM. So we start discuss about it in detail one by one. Java program normally go through 5 phases: edit, compile, load, verify, and execute. First stage is edit. Program is created in an editor, store on disk with extension .java. As we create our Java program in Notepad and save it as with extension .java. For example, our program is hello, and then we save it as hello.java. Then second stage is compile. When we compile our source code, Java compiler is required for compilation. And when Java compiler compiled a source code, it generate bytecode. In Java, as we know, source code converted into bytecode by compiler. So bytecode will be stored on our disk with extension .class. Means if our program is hello.java, then bytecode file will be stored as hello.class, and it's stored on disk, means memory. Then load. Class loader reads the .class file containing bytecodes from disk and puts bytecode into memory. Stored on disk means it is stored on secondary storage. As we know, the executed program must be in memory, cache memory, primary memory, because that these memories are fast for execution. So our bytecode file is stored on disk. So we, for execution, we have to need to load it from disk to memory. So class loader load our bytecode file from disk to memory. Then fourth stage is verify. Bytecode verifier confirm that all bytecode are valid and do not violate Java security restrictions. When bytecode is loaded in memory, then verification is done. Bytecode verifier verify that bytecode are valid and do not violate Java security restrictions. For this reason, Java is secure, because if bytecode have some security restrictions, violate Java security restrictions, then it will decline it. So that's why at stage bytecode is verified by bytecode verifier. At the last part of stage is execution. To execute Java program, we required JVM. So JVM reads bytecode and translate into them into language, machine language that our computer can understand. So at execution program, JVM read bytecode and generate machine code. As program executes, it may store data values in primary memory, because we use variables in our program. So as the result stored in variables, so we may store data values in primary memory as the program executes. So that's all about the stages for Java. Then our topic is a reason. What is the principle of for creating Java programming? Principle for creating Java programming was simple, robotics, portable, platform independent, secured, high performance, multi-threaded, architecture neutral, object oriented, interpreted, and dynamic. These are the features of Java that become it popular. We will discuss about it in detail, our topic features of Java. Java was developed by James Gosling, who is known as the father of Java in 1995. James Gosling and his team members started the projects in early 90s. So Java developed by James Gosling, that who was known as the father of Java. James Gosling and his team members started his project in early 90s. Currently, Java is used in internet programming, mobile devices, games, e-business solutions, etc. As we know, most of the application developed in Java, most of the games developed in Java. So nowadays, Java is used in various sectors like mobile devices, games, internet programming, and e-business solutions. Now we will discuss about history of Java. Firstly, Java is developed in 1991 by James Gosling and his team members. The small team of Sun engineers called the Green Team. In 1991, James Gosling is team members team known as Green Team, and in 1991, Java is developed by James Gosling and his team members. Initially, it was designed for small embedded devices in electronic appliances such as set-top boxes. When Java is developed in 1991, it is used for small embedded systems like set-top box, washing machines, microwaves, etc. Firstly, it was called Green Talk by James Gosling, and his file extension was .gt. Firstly, files of Java stored with the extension .gt. After that, it was called awk and was developed as the part of the Green project. The first name of Java was awk. Why awk? Because awk is a symbol of strength and chosen as national tree of many countries. So that's why this language is named as awk, because it is a powerful language for that time. So it is the symbol of strength and chosen as national tree of many countries. So that's why awk is used as that name. So first name of Java was awk. Then in 1995, awk was renamed as Java. In 1995, it renamed as Java because it was already a trademark by awk Technologies. Why they had choose the name Java for Java language? Because team gathers to choose a new name. They suggested multiple names like Dynamic, Revenantly, Silk, Jolt, and DNA. But they want a name that reflect the features of Java. They wanted something that reflect the essential of technology: revelatory, dynamic, lively, cool, unique, and easy to spell and fun to say. Team members want a name that reflect the features of Java language. So that's why Java is chosen. Initially developed by James Gosling at Sun Microsystem and released in 1995. Java is developed in 1991 but released in 1995. And Java was one of the 10 best product of 1995 in Time magazine. And JDK, because JDK is required for Java, JDK 1.0 was released on January 23, 1996. And after first release, there have been many additional features added to the language. Means there are many versions of JDK comes. Now Java is being used in window applications, web applications, enterprise applications, mobile applications, cards, etc. Each new version adds new feature in Java. So Java is used in window application, means our window related applications, web applications, enterprise business related applications, mobile related applications. So each version adds some new features in Java. Java versions. In 1995, there was alpha beta version, and then JDK 1.0, 1.1, 1.2, up to SE 18. So you can go through this about Java versions with their name and releasing dates. So here we have current stable release of Java is Java SE 10. Also we have SE 11, Java SE 11 to Java SE 18, but stable version. Stable version is Java SE 10.